Welcome to Ask and Learn.
This question is testing our knowledge to radioactive decay. So let's first see question A. Why are argon 40 over potassium 40 ratio used to date materials rather than calcium 40 over potassium 40 ratios? So this is because the decay of argon 40 may not be the sole source of calcium 40. Calcium 40 is a small molecule, maybe another radioactive atom can also decay into calcium 40. Then we can't use, so we don't know how many percent of that atom converted to calcium 40. And question B, what assumption must be made using this technique? There are two assumptions that have to be made. First, the decay of argon 40 has to be the sole source of potassium 40, and also we have to make sure the potassium 40 is not lost over these years. And let's see question D first. Question D, why will the measured age of rock compared to the actual age if some argon 40 escaped from the sample? If the carbon 40 is some argon 40 is escaped, then the measured ratio is less than the actual ratio, because the measured ratio is proportionally related to the calculated time. So if the measured ratio is less than what is supposed to be, the calculated time should be less than what it actually is. And then let's see the C. If the argon 40 over potassium 40 ratio is 0.95, calculate the age of the rock. So let's assume the mass of the potassium 40 is 1 gram, then will the mass of the argon would be 0.5 gram. The question, we know 10.7% of potassium decayed to argon. Potassium 40 decayed to argon 40. So the initial mass of potassium should be 10.7% times m equals to 0.95 gram. So the m is the 8.9 gram is the of potassium that decayed. So the initial mass of potassium should be 9.8 plus 1, which is 9.9 gram. So the ratio is 1 over 9.9 gram ln. This ratio equals to negative t, calculated from the half. So we know it has been 4.2 10 to the power of 9